So sometimes in Rust, we would like to store a series of data that can grow and shrink at will. Now we've already covered the compound types, which are arrays and tuples, but in most cases they're not going to serve you really well. You're not going to achieve what you need to achieve using them. So here is a better alternative, and it's called the vector type. So a vector type in Rust is a dynamic array that can grow or shrink as required. It's like an array, but it can grow and shrink, but an array couldn't. So what Rust does is, as you keep adding more values to the vector, it will keep growing the memory that you need, just like a string object in some ways. So in this video, we are going to cover how to use the vector type in Rust, how to add data, how to remove data, how to update data, and then how to loop through the data, because you can loop through the data in a vector, just like in an array. But first, you usually need to use a vector when you want to store a collection of items of the same type. So the key fact here is all the elements in the vector must be of the same type, just like in an array. Or you need to dynamically add and remove items from your collection. Then you can use a vector. Or maybe you need to store some numbers or any other type of data that you don't know how big it's going to get beforehand. Then vector is your guy. To understand how the vector type works, I suggest you also watch the video where we explained compound types in Rust. I broke down tuples and arrays in that video. Once you understand how they work, you can easily understand how vectors work, because they work much similar. They are quite similar, but you can achieve more with vectors than arrays or tuples. So first, let's take a look at how to create a vector. So you start by creating a variable. Let's say we want to store a series of numbers, okay, and we called it nums. Now you have to provide the type of values that must be stored here, and they must be of the same type. You can say there will be iter2 types, and then you create the vector. I'm going to show you 3 ways to create the vector. First, by using the new associated function inside the vector struct. So you can say vec, okay, and then you use new. Now this will create an empty vector. If you bring that to the terminal, and if you run that code, you get num is equal to empty. You can see that it looks like an array. It's similar to what you will see when you print array to the terminal. Okay, for example, if you have an array, now we have this array that we've defined here, and we are printing it to the terminal. And when we run the code, you see that it looks similar to a vector. Okay, now the second way to create a vector. Is to create it from an array. You can just say array of 1 that contains 3 values, and then you convert it to a vector by calling to vec on it. Okay. Now the beauty of vector is that unlike an array, you can modify it. You can add more values to it, and I'm going to show you that in a second. Now the third way you can create a vector is by using the vector macro. You can use the vec macro, and then you provide the vector 1, 2, 3. It's like you're calling the vec macro, and then you're passing an array to it. This will also create a vector, and if you print that to the terminal as well, you will see that it has these values 1, 2, 3, which is what we created. Now let's see how to modify the values of a vector. Now we have these nums. We can add more values by calling push on it. Let's say we want to push the value 4 inside it, and because our variable is mutable, we can push as many things as we want. For example, we can push another value 6, and if we run that code, you see that we now have the 4 and 6 that we just added to the vector. Now, how do we read values from a vector? So pay attention that when we are creating the vector, we have to provide the types. In some cases, if you don't provide the types, Rust will do that for you. For example, if we remove this type, Rust will infer because we've provided integer values here while creating the vector, Rust will infer that the type of vector we created is of type iterary2. But I suggest you always provide the type. It will make you more aware of your code, and you'll be more careful when you code, when you provide the types yourself. Okay, so let's see how to read values from a vector. Now, there are two ways to read values from a vector, and I'm going to show you the two ways, their similarities, and also their differences. So first, let me show you how to read the item from an array by index. Let's say we want to read the first value. We could just access the vector and then read the first value as if you are reading it from an array. Now, pay attention to what will happen here. If we print this to the terminal and if we run the code, we get the first value, which is set to 1 here. Now, the second way to read the value from a vector is to use the get method on a vector. For example, if we want to read the second value, you can just do that by reading num, and then we'll call get on it, and then we'll get the second value. Since it starts counting from the index of 0, we give it 1. And let's print that to the terminal as well. And when we run that code, we get something different. You can see that we're getting sum 2. We actually got the second value, but it's inside this sum. So I explained in the previous video what this means. You can check out that video. I dedicated the video to explaining the options API, the options enum in Rust, and how it is used to guard against the null reference. Okay, so Rust is simply saying here that at this point, this second value in this vector contains some value. That is why it says sum, and the value is 2. If you look at this definition here, you can see that Rust has inferred that the type is actually of options, but of type iterary2 by reference. So what this does is that when you use the get method, Rust will return an options enum for you. Okay, and the difference between this accessing the vector value by index and accessing it by using the get method is that the get method doesn't cause your program to panic. And let me give you an example. Since we have just 3 values inside this vector, if you come back here and we try to read like index 10 from it, you know it's not going to exist. And if we run that code, our code will panic. You see, Rust says thread man panicked at index out of bounds, and it says the length is 5 but the index is 10, which is another way of saying we have just 3 values here, but we are trying to access the 11th one. Okay, so it's not going to work. So if you want your code to panic while accessing the vector, if it doesn't exist, if that index doesn't exist, then you go this route. Let's try the same thing with the get method. Now watch what will happen. Sorry, let's fix this. Now when we run that code, you get none. Before we got sum and the value we were looking for, which was 2, and now we are getting none. Okay, this is the second variant in the options enum. So what Rust does is, when you use the get method, if the value doesn't exist, it will just set it to the variant none. However, if the value exists at that index, then it will set it to some value. This way, it's not going to panic. It will just give you a value of type options. Okay, so what you can do here is to use the match expression to check if this second contains something or not. You can check out this video where I explain the match expression fully. Okay, so what you do is you say match, you type in match, and then you pass what you want to match, and then you have to provide implementation for all the variants. Okay, here we can say, okay, so since second might contain a value at some point and no value at a point, let's check what we can do when it contains nothing. If it contains nothing, we can just print something to the terminal. You can say nothing. You can do whatever you want to do at this point, but if it contains some value, okay, we can then do something. this is when we can now read the value. We can now say the value, and then we have to read the value here. Let's just say x. So if the value exists, then it will be of type x. It's going to be stored in x, and then we can now say x is equal to this. Okay, and watch what will happen when we run the code. Let's comment these ones out. Now that we run the code, it says it printed this, saying nothing. But if you set it back to a value that exists, or an index that exists, and run the code again, it will now print x is equal to 2. So this is how you access the value. You can then make your choice of if to go this route or this route. For the most part, I will suggest going this route by using the get method, because if you try to use this and then the value doesn't exist at runtime, your code is going to panic. But if you go this route, then you make sure that you will always check for when the two conditions, for when it is none or some value. So make sure you check that video where I explained the options enum, because it's very, very important in Rust. Okay, this is how you say something can be of this value, but it's not there yet. You can then check by using the match expression. So how can you remove a value from a vector? Okay, let's say we want to remove some value. You can use pop to pop the last value. Actually, pop will also return the last value that we just removed, but it will also return a type, a value of the options enum type. So we can just read it here, popped, and then we set it to that, but it's going to be an option, because what we are popping, if no value exists in the vector at that point, then it's going to return none, which is a variant in the options enum. If there is a value in it, then it will return some, that value, then you can then convert that value to the type you want. So remember that the ownership rule still applies to a vector. For example, we have this vector right here, and we are able to push in some values here. But if someone has borrowed this value at some point, we will no longer be able to push anything inside it. For example, if we have a variable that we call a, and then we read something from it, and then we read something from the vector. Let's say we read the second value. Now we have this variable here, okay, and we are reading some value. Let's say we read the first or the second index from this vector, even though we are reading it by reference, okay, and Rust will be watching us to see what we'll do next. We came down here after we must have borrowed this, after we must have assigned the value by reference to this number, to this variable a, okay, and Rust will not do anything. But once we decide to use this variable a, for example, if you come down here and then use that value a for something else, you see that Rust will start warning us here. It says cannot borrow norms as mutable, because it is also borrowed as immutable. And let me use this opportunity to point out that when you have a vector and you borrow one value of it, like here, to another value, okay, Rust will consider the ownership moved as well. That is why you can no longer add some value here, because you've just borrowed the value. Rules like this that Rust is implementing, is it not going to be a bottleneck? Like imagine you have a vector, but once you've assigned it to assign just one item from it into another variable, you can no longer use it because the ownership has been moved. You can no longer assign more values or do any other thing to it. And that is true. Why that is the case is this: when you understand how Rust stores vector values in the memory, you understand why this happens. Okay, what Rust does is, as you keep giving it some value, like we gave it some value here, it will store it in the memory. It will store this one, and then store this one, and then store this one. At the end of that memory, other values could also be stored from other variables. Now if you add more values and there is no more space to add it there, Rust will move this to another space where it can contain the new values. Okay, so if you have a reference to just one item, like we did here, if it happens that this has been moved to another space, then the reference you will have to that value, if you're able to add new values here. So if that happens, and then you have the reference, and then you add new value, and that resulted to Rust allocating new space for this, then that will invalidate this, and therefore A right here will be pointing to a memory that has been deallocated already. Okay, so in order to prevent this, Rust makes it in such a way that vector, once you move one item inside a vector, you can no longer modify the vector itself. Now, as I mentioned earlier, you can also look through a vector. Okay, so here we have this variable called nums, which is a vector type. Okay, with the for loop, you can just say for x in nums. Okay, and we'll start looping. You can access that by reference, and then we'll start looping through. We can then print in the values. X is equal to, this has to be this. Okay, so we read that by reference, and then if we run that code, you get the values printed to the terminal. So you can loop through a vector just like an array as well. Now it's not a must that you must access this as a reference. You can remove this as well. But why I'm accessing it as a reference is I didn't have any intention of changing it here, so I could just access it as a reference. Now there is another problem. Remember earlier that I told you just like an array, a vector can only hold one type, just like you see here. So you can only store integers of type i32 inside this vector. Okay, and in some cases you might need to store more than just one type. Okay, and this is where the enum comes in. You can check out this video where I explained enums in detail. We can use enums to create different types of value, and this will allow us to iterate through them here. Okay, for example, let's say we have an enum. Now let's call it num kinds. Okay, and then here we can now have different kinds. For example, we can have i32 kind, we can have i64 kind. Now we can now come in here and say that this vector can accept this type of num kind. So first, pay attention that this way the vector can also contain enum kinds. Okay, but the problem is that it will say mismatch of type. You can see that here it's pointing out that these values does not match with what we have here. Okay, so what we can do is to give it a name. So you can say i32. Notice that this is different from the type we have here, and then we say it will accept this type, this value. Okay, we can now convert this to a capital letter as well, and then we will say it will accept i64. Now over here, what we can now do is to use the variant. You can now say num kind. If we want i32 value, you can now say i32, and then we pass the value 3. You can do the same thing for the rest as well. You can now add another type of can now use the other variant i64, and then we pass an i64 value as well. So this way we will achieve the ability to use more than one type, to store more than one type of values inside a vector. I hope this is very clear. If you have more questions, do leave it in there so that I can go through them and then give you some answers as well. Remember to like the video and subscribe so you get notified when I release more videos.